Okay, so for this next question, I should have been a little more specific, but we're looking at when we're doing beta oxidation in terms of when it's in cis form. So let's just start with this group right here. I drew them just so that way it's easier and I don't waste time. So when you have a structure like this, in which, these are not numbered correctly, but in which we have 7 carbons, and these carbons right here, let's just assume that they're saturated. So these carbons right here can, or like this entire fatty acid, can go through beta oxidation. Technically, after 3 rounds of beta oxidation, we lose 6 carbons. So let's just say that instead of the 7 CH2, now we only have this one right here, which I'm putting a star next to, and the remaining that we have here. So what happens is, once we get rid of the carbons and the double bond is closer to the carbonyl, we start getting to complications in terms of how beta oxidation can go. We actually need an additional step because beta oxidation cannot occur in its cis form at the 2nd position or the 3rd position, depending on what you're looking at. So we're always doing beta oxidation when it's closest to this carbonyl group right here. So this group right here. So I'm just going to draw it here, how it looks like after the 3 rounds of beta oxidation. So we end up with something that looks like this. So now we lost 6 carbons, right? So we don't have 7. This one right here is replicating this one right here, except instead of 7, we have just a single carbon since we lost 6 carbons. So now, and I'm just going to draw an R here to denote the remaining since that doesn't matter. So now we have carbon 1, 2, 3. So now this is called cis I'm missing a carbon. Sorry, I keep numbering these wrong. You always want to start with the carbonyl. 1, 2, 3, 4. Cis delta 3 enyl CoA. So the problem with continuing the beta oxidation with this is we have a cis. And beta oxidation can only proceed in the trans form because the cis form is not a substrate for this enyl CoA hydratase. That's right here. It must be in the trans form. As we see in the beta oxidation in the previous question, it's in the trans delta 2 form. So what we have to do is we have to add an enzyme to get it to this one right here. And that enzyme is called enyl CoA isomerase, which just converts this cis form into this trans form. So we have 1, 2, 3. That trans form is at the 2nd carbon. So now this is called trans delta 2 enyl CoA. So make sure you remember this enzyme because it's very important for beta oxidation to proceed. So once you get to this form right here, you can actually continue on as if you were to do the normal beta oxidation. So now this structure right here looks like a complete mess, but it can actually start at this step right here, in which we have enyl CoA hydratase, and then that can be converted into L-beta hydroxy acetyl CoA and so forth.